Hello everyone, welcome to the mathematics class and I am Sandeep Jaiswal. This video is for class 10th students. Today we will start our second chapter, polynomials. Before we start our chapter, you all should know what is a polynomial. Polynomials are the algebraic expressions in which the exponents on the variables are whole numbers. Dear students, you all have already studied polynomials in class 9, so here I won't deal in much detail, but some of the features of the polynomials will be discussed here again. Dear students, please do remember these features as they are the basic things about polynomials, and also do remember that to deal with greater problems we should know about the basic things. The first one that we are going to deal is degree of a polynomial. The highest power of the variable in a polynomial is called the degree of the polynomial. For example, let us see the polynomial 2x plus 7. Here the highest power on the variable is 1, therefore the degree of the polynomial is 1. In the second polynomial here, 2x square plus 5x plus 3, the highest exponent is 2, therefore the degree of the polynomial is 2. In the next example, 4x cube plus 3x square plus 7x minus 1, the highest exponent on the variable is 3, therefore the degree of the polynomial is 3. The fourth polynomial here, 5, which is also a constant, so here there is no variable, so the power on the variable will be considered as 0, therefore the degree of the polynomial will be 0. Also the polynomial is called as constant polynomial. So a non-zero constant polynomial has the degree 0 always. In the next polynomial, which is 0, we call this polynomial as zero polynomial, and degree of a zero polynomial is not defined. Now make a note that the polynomial with degree 1 is called as linear polynomial, and the polynomial with degree 2 is called as quadratic polynomial. The polynomial with degree 3 is called as cubic polynomial, and the polynomial with degree 0 is called as non-zero constant polynomial, and the polynomial in which we have the only term 0 is called as zero polynomial. Now let us see how to find the zeros of a polynomial. Let us take a polynomial here, x square minus 3x minus 4. Let us substitute x equals to 1 in the above polynomial. So here we get p1 is equal to 1 square minus 3 into 1 minus 4. Here we have replaced 1 with x. In the next step, we will get 1 minus 3 minus 4 equals to minus 6. Therefore, p1 is equal to minus 6. Thus, we say that the value of px at x equals to 1 is minus 6. Next, we will substitute x equals to minus 1 in the above polynomial. So, we get p minus 1 equals to minus 1 whole square minus 3 multiplied by minus 1 minus 4, which is equal to 1 plus 3 minus 4 equals to 0. Thus we say that the value of px at x equals to minus 1 is 0. So here make a note that since on substituting x equals to minus 1 we get p minus 1 equals to 0, therefore we say x equals to minus 1 is a 0 of the polynomial px. Also, when we substitute x equals to 4 in the above polynomial, we get p4 equals to 4 square minus 3 multiplied by 4 minus 4, which is equal to 0. Thus, we can say that x equals to minus 4 is also a 0 of the polynomial. Therefore, Px has two zeros, that is x equals to -1 and 4. Now we will discuss about the geometrical meaning of the zeros of a polynomial. At first, let us see the geometrical representation of a linear polynomial and the geometrical meaning of its zero. To do so, let us take an example of the polynomial y equals to 2x plus 3. We know that a linear polynomial represents a straight line on the graph, so we will find the values of x and y to plot the graph. So you can see the values of x and y in the table, and the graph of the polynomial is represented on the right side. The graph of y equals to 2x plus 3 is a straight line, and you can see that the graph is cutting the x-axis at -3/2, 0. Also, if we take 2x plus 3 equals to 0, we will get x equals to -3/2, which is a zero of the polynomial y equals to 2x plus 3 here. Thus, the zero of the polynomial 2x plus 3 is the x coordinate of the point where the graph of y equals to 2x plus 3 intersects the x-axis. Therefore, make a note that the linear polynomial ax plus b, where a is not equal to 0, has exactly one zero, namely the x coordinate of the point where the graph of y equals to ax plus b intersects the x-axis. Thus, we conclude that the graph of the polynomial cuts the x-axis at only one point, therefore it has only one zero, and the x coordinate of this point is the zero of the polynomial. Next, we will discuss about geometrical meaning of a zero of a quadratic polynomial. Let us take the quadratic polynomial y equals to x square minus 3x minus 4. Here we can see the values of x and the respective values of y in the table given here. Now, if we locate the points listed in the table on a graph paper and draw the graph, it will actually look like the one given below. The graph of the above quadratic polynomial is a parabola that you can see here in the figure. You can see from the table above that -1 and -4 are zeros of the quadratic polynomial. That is, when we substitute x equals to -1 and -4, we get the value of y 0. Also note from the figure that -1 and 4 are the x coordinates of the point where the graph of y equals to x square minus 3x minus 4 intersects the x-axis. If you see the figure carefully, you can clearly find that the graph cuts the x-axis at -1 and 4. Thus, we conclude here that the zeros of the quadratic polynomial x square minus 3x minus 4 are x coordinates of the points where the graph of the polynomial intersects the x-axis. Therefore, the zeros of a quadratic polynomial ax square plus bx plus c, where a is not equal to 0, are precisely the x coordinates of the point where the parabola representing y equals to ax square plus bx plus c intersects the x-axis. Dear students, please note that these basic points are very important for you all, because the objective questions comes on these basic concepts only, and it confuses if the basic points are not clear to you all. Now, from the above observation about the shape of the graph of y equals to ax square plus bx plus c, the following three cases can happen. Case 1. Here the graph cuts x-axis at two distinct points a and a dash. Therefore, the x-coordinates of a and a dash are the two zeros of the quadratic polynomial ax square plus bx plus c in this case. In the case 2, the graph cuts the x-axis at exactly one point, or we can say at two coincident points. So the 2 points a and a dash of case 1 coincide here to become 1 point A. Here the x coordinate of A is the only zero for the quadratic polynomial ax square plus bx plus c. In the third case, the graph is either completely above the x-axis or completely below the x-axis. So it does not cut the x-axis at any point. So the quadratic polynomial ax square plus bx plus c has no zero in this case. So you can see geometrically that a quadratic polynomial can have either two distinct zeros or two equal zeros, that is 1 0 or no zero. This also means that a polynomial of degree 2 has at most two zeros. Next we will see geometrical meaning of the zeros of a cubic polynomial. For the explanation, let us take the cubic polynomial y equals to x cubed minus 4x. Here in the table we have some values of x and the respective values of y for the given polynomial. If we locate the points listed above on a graph paper and draw the graph, it will actually look like the one given below in the figure. We see from the table above that minus 2, 0 and 2 are zeros of the cubic polynomial x cubed minus 4x. Here observe that minus 2, 0 and 2 are in fact the x coordinates of the only points where the graph of y equals to x cubed minus 4x intersects the x-axis. Since the curve meets the x-axis in only these 3 points, their x-coordinates are the only zeros of the polynomial. That is, minus 2, 0 and 2 are the only zeros of the polynomial. Let us now discuss another cubic polynomial, y equals to x cubed. Here in the table we have some of the values of x for the polynomial and the respective values of y. And the graph of the polynomial is just shown here in the figure. Note that 0 is the only zero of the polynomial x cubed here. Also from the figure you can see that 0 is the x coordinate of the only point where the graph of y equals to x cubed intersects the x-axis. Therefore, x equals to 0 is the only zero of the polynomial. Let us take one more cubic polynomial, y equals to x cubed minus x square. Here in the table we have some of the values of x for the polynomial and the respective values of y. Also you can see the graph of the polynomial drawn here in the figure. Here 0 and 1 are the only zeros of the polynomial x cube minus x square. Also, from the figure, these values are the x coordinates of the only points where the graph of y equals to x cube minus x square intersects the x-axis. From the examples above, we see that there are at most 3 zeros for any cubic polynomial. That means a cubic polynomial can have 1 zero, 2 zero or 3 zeros or even no zeros. In other words, any polynomial of degree 3 can have at most 3 zeros. Thus, from the above examples we conclude that linear polynomial has at most 1 zero, that is 0 or 1. Quadratic polynomial has at most 2 zeros, that is 0 or 1 or 2. Cubic polynomial has at most 3 zeros, that is 0 or 1 or 2 or 3. Thus we conclude that for any polynomial px of degree n, the graph of y equals to px intersects the x-axis at most n points. Therefore, a polynomial px of degree n has at most n zeros. Now, let us solve one example. Look at the graphs in the figure given below. Each is the graph of y equals to px, where px is a polynomial. For each of the graphs, find the number of zeros of px. Here in the first figure, the number of zeros is 1 as the graph intersects the x-axis at one point only. Here in the second figure, the number of zeros is 2 as the graph intersects the x-axis at 2 points. Let us see the third figure. Here the number of zeros is 3 as the graph intersects the x-axis at 3 points. In the fourth figure, the number of zeros is 1 as the graph intersects the x-axis at 1 point only. This is the fifth figure. Here the number of zeros is 1 as the graph meets the x-axis at 1 point only. Now we are seeing this last figure. Here the number of zeros is 4 as the graph intersects the x-axis at 4 points. You may have some more complicated figures, but if you know the basic concepts, you can easily solve any type of figure. Dear students, you all are requested to please do the home assignment mentioned here. Please solve exercise 2.1 of NCERT textbook. Thank you everyone for watching the video. And I request you all to please subscribe, like and share my channel so that you can receive the updates of the upcoming videos.